बिस्मिल्लाहिर्रहमानिर्रहीम। तो आज का जो हमारा टॉपिक है बहुत ही इम्पोर्टेंट क्लास इज दिस वन, क्योंकि इसमें ज़्यादा मैटर अच्छी तरह मिलता भी नहीं, उतनी एक्सप्लेनेशन भी नहीं है कंटेंट में। और तो काइनेटिक्स ऑफ कोपॉलीमरेशन। अब कोपॉलीमरेशन हम जानते हैं कि जब भी हमारे पास कोई प्रोसेस हो जिसमें एक पॉलीमर बनता है जिसमें दो डिफरेंट टाइप ऑफ मोनोमर्स प्रेजेंट होते हैं, सो दैट्स कॉल्ड एज अ कोपॉलीमर। एंड काइनेटिक्स, व्हेन वी से काइनेटिक, दैट मींस एक्चुअली डीलिंग द रेट ऑफ द रिएक्शन, which what are the factors actually that will the influence the rate of the reaction. तो काइनेटिक्स ऑफ कोपॉलीमरेशन। सो हम लोग क्या करेंगे, स्टार्ट बड़े आसान तरीके से, ज़्यादा हम डीप नहीं जाएंगे इसमें। विल टेक अ कोपॉलीमर फॉर एग्जांपल विच इज कंपोज्ड ऑफ M1 and M2. So for example, this is a copolymer. Now this is a copolymer. M1, M2. Copolymer, it is formed through the free radical mechanism. Free radical mechanism. Free radical mechanism. So that means we have initiation step here, we have propagation step, we have termination step. In the initiation step, we have generation of free radicals, and the initiators are monomers with active sites. So in the initiation step, we have formation of radicals like this one and M2, are molecules which have active sites, then which can participate in the propagation step. And then these two monomers, they participate in the propagation step. So I'm showing two radicals now. Because we have a copolymer, so this can also form the free radical, this can also form the free radical in the initiation step. Now as far as the kinetics is concerned, for kinetics it is important that we have actually the rate will be determined by the propagation step. So what I will do, I will just mention it here. So please keep this in the mind. We have a copolymer with monomers M1, M2 arranged in different fashion, whether alternate or whatever. Reaction proceeds through a free radical mechanism, and in the initiation step we have formation of monomers, and then these monomers actually they participate in the propagation step and they build the chain onwards. So we have both these monomers actually build the chain. Now we have four possibilities in the propagation step. It's actually the propagation step that will determine the rate of the reaction. So for determine the kinetics of copolymerization, so we're actually dealing with the propagation step. So main step is propagation step. Propagation step. So there are various possibilities in the propagation step. First possibility is that this was we have generation of radical 1, a chain has a radical M1, and then that reacts with monomer of its same. Second possibility, that this radical 1, a chain with a radical 1 which is formed in the initiation step, that reacts with a different monomer, because both are present in the solution or both are present in the reaction mixture. The third possibility is that the chain has a radical M2, and then that reacts with the same monomer of itself. And then we have a fourth possibility, that the radical of M2 that reacts with different monomers. So these are the four chain propagation steps on which this chain gets built up. So we can see it like this. So here we are having formation of M1, M1, and the radical is here that propagates. So this is chain propagation step. We'll add the rate constant for propagation of 1, 1. So 1, 1. Likely step number 2, we have M1. Now we have the radical and M2. Fine. So we have kinetic, this is rate constant, propagation, that's 1, 2. And then we have here formation of, sorry, it is 2, M2, M2, and radical on 2. The rate constant for propagation 2, 2. Right? And then we have last one where we have this type of possibility will exist, that we have M1 and then active site on the M1, so it is a rate constant for propagation, it is 2, 1. तो ये चार हमारे पास जो है, these are the 4 steps which lock on the propagation steps, जो हमें rate of, जहाँ से rate of रिएक्शन डिटरमाइन कर सकते हैं, काइनेटिक्स ऑफ कोपॉलीमराइजेशन. इन दो में भी अगर आप देखेंगे, जो हमें बाद में जरूरत होगी, इसमें डिफरेंट मोनोमर्स रिएक्टिंग सोच जैसे कोपॉलीमर फॉर्मेट, डिफरेंट मोनोमर्स और कोपॉलीमर, ये दो होमोपॉलीमर्स. तो ये दो दीज आर द मेन इंपॉर्टेंट रिएक्शंस जो हम लेटर देख लेंगे. तो फॉर द मोमेंट दीज आर द 4 प्रोपेगेशन स्टेप्स. नाउ बिफोर वी प्रोसीड, हम लोग यहाँ पे कुछ एज्यूम करेंगे. एज्यूम हम ये करेंगे कि जो एक रिएक्टिविटी ऑफ पर्टिकुलर रेडिकल, एक पर्टिकुलर रेडिकल की रिएक्टिविटी जो है, that will be independent of size of the chain or the composition of the chain. So we assume that, so we make some assumptions that the reactivity of a particular radical that does not depends on the size of the chain, that depends on the कंपोजिशन की, एक पॉलीमर चेन में किस तरह का कंपोजिशन फॉर्म हुआ, किस तरह का अरेंजमेंट है, कंपोजिशन ऑफ द पॉलीमर. नाउ व्हेन वी मेक दीज अरेंजमेंट्स, द कंपोजिशन ऑफ द चेन, उसके बाद नाउ व्हाट विल डू, वी विल स्टार्ट द रेट ऑफ द रिएक्शन. Now we know that this monomers, whether it is M1 or whether it is M2, they are consumed in these 4 steps. Okay? So now we start calculating the rate of monomer consumption. Okay. So the rate of monomer consumption. Start calculating the rate of. We'll drop this क्योंकि थोड़ा सा हमें जगह में भी मसला हो जाएगा. तो rate of monomer consumption, rate of monomer consumption कैसे दिखाते हैं हम काइनेटिक्स में. हम फॉर एग्जांपल अगर हमें M1 को दिखाएंगे तो हम लिखेंगे द माइनस कंजप्शन d/dt ऑफ, फॉर एग्जांपल मोनोमर M1, रेट ऑफ मोनोमर कंजप्शन. सो दैट कैन बी कैलकुलेटेड फ्रॉम, अब M1 किस में कंज्यूम होता है, स्टेप इसमें M1 कंज्यूम होता है और M1 कंज्यूम. सो फ्रॉम दीज 2 स्टेप्स वी विल कैलकुलेट रेट ऑफ मोनोमर कंजप्शन. सो दैट कैन बी कैलकुलेटेड एज, so rate of monomer consumption. So that is basically Kp11 multiplied by the molar concentration of M1, this active site of the chain, and M1. So that is basically Kp11 and this is M1 dot and M1 and plus where it is that further, that is Kp21. Kp21 is here, that is M2 plus Kp21 M2 M1. So the rate of monomer consumption M1, likely we'll calculate the rate of monomer consumption M2. Rate of monomer consumption, rate of monomer consumption M2, it can be calculated through M2 is consumed in this step and this step. That's consumed, monomer is consumed in M2 here, so that's Kp12. So we'll write KP12, KP12, and then we have M1 dot M2, M1 dot concentration of molar concentration of M2 plus KP22 M2 dash M2 plus KP22 M2 radical and M2 KP22 M2 M2. So ये हो गई आपके दो steps. The rate of monomer consumption M1 and rate of monomer consumption M2 is given by these relationships. Now after that, so what we'll do, we'll divide, we'll write divide, write down divide. I will label them as let us label them with something 1 and 2, 1 and 2. So divide 1 by second. जैसे आप इनको डिवाइड करोगे, दो रिलेशंस को डिवाइड दिस वन बाय दिस वन, so what you will end up with that. By dividing this, we will actually trying to obtain the ratio of monomers M1. We'll get ratio of monomers of M1 and ratio of monomers, that is M2, and the ratio of mono M2 in a particular copolymer. So the ratio of monomers M1 and M2 in a particular copolymer. So this ratio on this side, which is the right hand side, so this ratio will designate by gamma. So this ratio is basically the ratio of number of molecules, ratio of number of molecules of M1 to the M2 in a particular copolymer, of M1 to the M2 in a particular copolymer. So this ratio we are designated by gamma. Now when we divide this and this, so what we'll get, so I will not go here, I will straightforward take it here. So we'll divide this by this, so we'll end up with a step like this. We have gamma here, it's not working, gamma, that is equivalent to, so we have this relationship, very important relationship. Now this relationship we label it. So this relationship this will use for calculating the reactivity and others. So the ratio of monomers in a copolymer chain, the ratio of number of monomers of A and B in a coparticular chain is given by this one. So this will label as 3. Take. Now before that we'll start applying after that, now we always apply the steady state approximation. The steady state approximation, we know that we assume that a particular component hardly changes during a course of time. For example, steady state approximation में बोलते हैं कि A gets consumed to get B and B forms the products. Now if you can see the steady state approximation d by dt of B, so that is equal to 0. हम steady state approximation के the rate at which B is formed, the same rate at which B gets consumed. So I'll say that the change of B as a T is equal to, it's called steady state approximation, steady state approximation principle. So we'll apply steady state approximation principle here. So now let us apply the steady state approximation principle. Apply steady state approximation. When we apply the steady state approximation, now we can write that एंड स्टेडी स्टेट प्रोग्राम जैसे मैंने पहले कहा, अगर आप देखो किसको स्टेडी स्टेट प्रोग्रामेशन अप्लाई करेंगे, दो स्टेप्स वेयर वी हैव कोपॉलीमर फॉर्मेट. फॉर एग्जांपल हियर it forms M1 M2, it's a copolymer, and this forms a copolymer. So we'll apply to this step. I don't know, step number 2, this step number 2 here, and step number 4, step number 4. The applying steady state approximation in steps. So we can write down d by d, the rate of consumption of M1 monomer, that is called rate of formation of the second monomer, M2 dot, this is M2 dot, so that will be equal to 0. The rate of consumption of monomer M1 is getting actually ultimately consumed in this step. Here it is getting in this step, we are consuming this one. M2 is getting consumed. Fine. The rate of consumption of this, and that's called 0. Okay, so if we start calculating that, we can write down. Let us now use only M1. So rate of consumption of M1, that is given by, so that will be Kp11 M1 M2. So that will be Kp11 M1 M2. Second one, the contribution comes from this step, Kp21 M2 plus M1, sorry, into M plus Kp21 M2 M1, that's M2 dot M1. So this is equal to this. Fine, that can be called as equal to 0. Now from this I'm going to calculate M1 by, I'll try to calculate this ratio so that we can later fit this in this relationship. So this ratio is equal to, अब ये खुद आप निकाल सकते हो आप इसको डिवाइड करके, because this is equal to 0. So this by this you'll end up with Kp यहाँ पे सर it was 1 2, क्योंकि ये वाला स्टेप है, it was 1 2, sorry. So it is Kp12, and then you can take it M2 divided by Kp21 M1. Now ये another important आपका जो relation हो गया, where we have tried to calculate this. So this will label as 4. Okay. So we'll label this as 4. So we have 4 and we have 3 now, important relations. Before we'll actually put this 4 in 3, हम लोग कुछ we'll try to make it simple as this. For example, okay, write it here. Now we'll say that if we have the rate constant Kp11, which is where both the monomers M1 M2 are actually forming a homopolymer, that is plus Kp, where monomers M1 and M2 they're forming a copolymer. This ratio Kp11, the rate constant of this Kp11, where both the monomers for A are monomers 1 are getting consumed. So their ratio, let us say this is equal to R1. That's the ratio of rate constants 1 and 1 2 monomer. Because if you see this relation, see look here, we have this ratio this by this. So now making this relation simple, let us say it is R1. And likely we'll keep Kp21 it is 1 1, I will keep 2 2, as usual. Ratio of the rate constant of this one and P to 1. So that is equivalent to R2. So now this is third relation. We keep it fifth. Now what you do, put this fifth and put this fourth in this relationship, that is third. So I can write down put fourth and fifth in third. So you will end up with a final relation. अब इसको मैं solve नहीं करूँगा. You can try this. You will end up with a relation that your ratio of monomers M1 to the M2 in a particular copolymer is given by 1 plus, we'll get solved like this, 1 plus R1 जो अभी रेट कांस्टेंट का रेशियो था, मोनोमर फर्स्ट के लिए प्लस 1 plus R2 rate constant का ratio for monomer second one. Then you will end up with long bracket. So you have M1 by M2. Take M1 by M2 and then you have M2 by M1. M2 by M1. So this is actually the final relation, which is called as the copolymer composition equation. So it is a final relationship which actually gives us the idea about the the kinetics of the copolymer. It's called as copolymer composition equation. So what this actually gives us, it gives us the number of monomers M1, their ratio in a particular copolymer. That actually depends on how many monomers will be there in a particular a copolymer. That depends on the rate constant of monomer M1 and rate M2. It also depends on concentration. So that we can say that a copolymer is formed at any given period of time. The composition of that particular copolymer, that is determined by the reactivity of the species M1 reactivity and as well as their concentration. So the composition of a particular copolymer which is formed at a given time, that actually depends on the composition as well as the rate constant at which the monomers get added up in the chain. Hope this was all for the kinetics of copolymerization, और मैंने बड़ी कोशिश की इसको एज वेल एज सिंप्लीफाई किया जाए, और ये बहुत बड़ा इंपॉर्टेंट टॉपिक है क्योंकि इसमें ज़्यादा मैटर जो है मिलता भी नहीं है. दिस इज ऑल फॉर द डे. इफ एनी वन यू हैव अ कंफ्यूजन, प्लीज डू कॉन्टैक्ट